Now we'll look at an example to calculate the equivalent resistance of a network. You can see here we have several resistors, each with resistance R, connected in series and in parallel combinations to a battery with voltage delta V. Now the first step is to look at this side of the circuit where we have three resistors connected in series, and this will give us an equivalent resistance for this part. R equivalent 1 equals to the sum of the resistances R plus R plus R, which is equal to 3R. And then we will move on to the next step. So we will be replacing these three resistors with a single equivalent resistor with resistance 3R. So that's what we do here. We have a single equivalent resistance with resistance 3R that replaced this part of the circuit. So we have now 3R and R connected in parallel. So you can see two resistors connected in parallel. The equivalent resistance will be the product of the resistances R multiplied with 3R divided by the sum of the resistances R plus 3R. So this will give us 3R squared divided by 4R, and that gives us finally 3R over 4. So this will replace this part of the circuit with an equivalent resistance 3R over 4, and we will have it connected in series with two different resistors with resistances R. So now this part is 3R over 4 connected in series with R on top and R at the bottom. So we will add the resistances R plus 3R over 4. So this has an equivalent resistance 2R plus 3R over 4, which gives us 4 times 2, 8 plus 3, 11, 11R over 4. So 11R over 4 will replace this part of the circuit, and it will be connected in parallel with R. So here we have 11R over 4 connected in parallel with R. So the equivalent resistance of this part will be the product R times 11R over 4 divided by the sum R plus 11R over 4. So this will give us 11R squared over 4 divided by, so this summation will be 4R plus 11R, 15R over 4, and then take the reciprocal. It's 4 over 15R. 4's will cancel, and also we will get rid of one of the R's here. So this will be just R, not R squared, and we will have 11R over 15. That's going to replace these two resistors. So 11R over 15 connected in series with two other resistors with resistances R each. So we will just add up the resistances. This will give us the final answer for the equivalent resistance as R plus 11R over 15. So that will be 2R multiplied with 15, 30 plus 11, 41, 41R divided by 15. So the final answer for the equivalent resistance of this resistive network is 41R divided by 15. Okay, so we have worked through an example for calculating the equivalent resistance of a resistive network. This is done in 5 steps, as you have seen here. The overall goal is to replace all of this with an equivalent resistance connected in parallel with delta V. And first we see that we have the same current flowing through these 3 resistances, so they will add up. We have 3R. Now this 3R is connected in parallel. They share the same voltage with R, so 3R and R parallel resistance is 3R over 4 because we need to take the product and divide it by the sum. Now this 3R over 4 equivalent resistance is in series connection with these two R's because they have the same current flowing. So we have 2R plus 3R over 4, 11R over 4. Now this 11R over 4 that replace these three will be in parallel connection with R, so they have the same potential. So that gives us 11R over 15, and that is finally in series with these two resistors. So we have to add up the resistances. This gives us our final answer, 41R over 15.